Good day everyone, welcome to part 7 of the supplemental video. So in this video we're gonna be answering force and torque on an electric dipole. So without any further ado, let us begin. Shown in the figure below is an electric dipole in uniform electric field of magnitude 5.0 times 10 to the power of 5 Newton per coulomb that is directed parallel to the plane of the figure. The charges are positive negative 1.6 times 10 to the power of negative 19 coulomb. Both lie in the plane and are separated by a distance of 0.125 nanometer, or that is 0.125 times 10 to the power of negative 9 meters. So these are the following that we have to find. First, we're going to look for the net force exerted by the field on the dipole. And second, the magnitude and direction of the electric dipole moment. Then C, the magnitude and direction of the torque. Then letter D, the potential energy of the system in the position shown. So let us focus our attention first in the illustration that we have here. So these pink lines are the electric field, and it is uniformly distributed to the plane. And we have the negative charge and the positive charge. They are separated by a distance, and as we can observe, if we try to look at here, this angle creates 35 degrees and this angle creates 145 degrees. So basically, illustration A shows the actual illustration of what is happening to the problem. Now, in letter B, what is shown here is the free body diagram. So, pinapakita dito sa atin kung saan yung direction ng electric field, yung torque natin, at yung dipole moment natin. And pinapakita rin dito na yung rotation natin is basically going to follow the direction from negative to positive. So, ang angle na i-adapt natin ngayon dito is the 145. Okay, the 145 degrees. And basically, electric charge flows from negative to positive. Okay? So as part of our solution, makikita natin dito na these are the only givens that we have. Okay? So let's try to answer letter A. The net force exerted by the field on the dipole. So basically, we already know that the electric field is evenly distributed throughout the plane, and those charges have the same magnitude. So basically, if we try to calculate the forces between them, the total force on the dipole would be 0. Okay? So there's no need for us to show that because basically that would end up with what we were expecting, since the electric field is evenly distributed and we have the same amount of charge. Now for letter B, the magnitude and direction of the electric dipole moment. So the magnitude of P of the electric dipole moment is vector P. So basically, we have to look for the magnitude first kasi mas madali dito. So dipole moment is equal to charge times displacement. Okay? So, basically, makikita natin dito that we simply multiplied the charge and the displacement that we have. So, the dipole moment is equal to 2.0 times 10 to the power of negative 29 coulomb meter. Okay? And the direction of our the direction of our dipole is to the positive charge. So that would be 145 degrees clockwise from the electric field direction. Okay? So let us move to letter C. Letter C is the magnitude of torque. So basically, since we're looking for the magnitude only, this is the only possible way that we can do this in a much easier way. So simply plug in all the values that are known. We have the magnitude of dipole moment, this is the electric field, and this is the angle that we should consider. So we have 5.7 times 10 to the power of negative 24 Newton meter. So this is our torque. Okay? Now, the potential energy. So since we are only looking for the magnitude of the potential energy, we use U is equal to negative P times electric field cos theta. So meron tayong type, meron tayong tawag nito, maling na type dito. That should not be signed. That should be cos 145 degrees. Let's see if we still arrive at the same answer. Baka nagkamali lang tayo sa pag-type. So, let's try that one. 2.0 times 10 to the power of negative 29 times 5.0 times 10 to the power of 5 cos 145. Oh la la. Our answer here, our potential energy is not this one. Our final answer should be negative 8.2 times 10 to the power of negative 24 joules. Okay. Yan. That is our potential energy. So that's it. So this ends our coverage for the prelim examination. Please review the examples and good luck to your exam. God bless.